right, we're going to do 4.2. So I need a whiteboard. Excuse me. All right. 4.2 has to do with systems, but in this case, there's not going to be 2 equations. There's going to be 3. 3 equations, 3 variables. So it's still solving systems of equations, but now it's going to look something like this. X plus y plus z equals 2. X minus y plus 2z equals 2. And negative x plus 2y minus z equals 1. X, y, z, 2. X, negative y, 2z, 2. Negative x, 2y, negative 1. The biggest mistakes that are made with these problems is not copying them down the right way. So that's why you saw me going over it very carefully. All right, we need to have an x, a y, and a z number. What number for x, y, and z will work in all 3 of these? That's what you're looking for, okay? Now, there are many, many ways to do this, and if you see other ways, then you go ahead. But what I have found, the best way to teach this is to teach it the exact same way, not going, oh, we could do this time or this that time, and then those who are struggling with this, they can't see a pattern. They can't see what exactly they're supposed to do. I'm going to do it the same way every time. And the first thing I do is I look at the first 2 and I eliminate the x's. Now, in order to eliminate the x's, remember elimination was you add them together and then they disappear. Right now, I have a 1x and a 1x they won't eliminate. But if I were to multiply one of these by negative 1, then they would eliminate, okay? So this becomes negative x, negative y, negative z, and negative 2. I distributed the negative 1. This does not change. X minus y plus 2z equals 2. The x's cancel out. You get negative 2y plus z equals 0 when I add them together. Negative 1y and negative 1y is negative 2y. Negative 1z and positive 2z is 1z, and negative 2 and positive 2 is 0. Okay. The next thing I do is I take the second and the third, and I do the same thing. I add them together and eliminate the x's. Well, look at how convenient it is. Will the second and the third automatically eliminate x's if I add them together? X minus y plus 2z equals 2, and negative x plus 2y minus z equals 1. Will that automatically, there's nothing I have to do. They automatically eliminate. I'm left with y plus z equals 3. Now, I have 2 equations with 2 variables. Let's move this over here. Look, it's y plus z equals 3. This is exactly what you dealt with in 4.1. So we know what to do. I either have to eliminate them or use substitution. I'm going to go ahead and eliminate because look what happens. Look at how easy I can eliminate. If I multiply this by positive 2, I have a negative 2y and a positive 2y, and they'll eliminate. Meaning, I'm not going to do anything with the first one. Negative 2y plus z equals, oops, I can't see with my 0. Okay, now distribute positive 2y plus 2z equals 6. The y's cancel out. I get 3z equals 6. I divide by 3, and I get z is 2. Now, I have a z, so I go back into either one of these to find out how to solve for the y. So let's just take negative 2y plus z equals 0, and in this case it's 2. I'm just taking the first one. So negative 2y plus 2 equals 0. Move the 2 over. I get negative 2y equals negative 2. Divide by negative 2, and I get y is positive 1. Okay, so I have y and I have z. How am I going to find x? Well, I have to go back to one of the original problems. I'll just take the first one right here. X plus y plus z equals 2. X plus y plus z equals 2. I don't know what x is, but I know y is 1. I know z is 2. So x plus 3 equals 2. How do I solve for x? Move the 3 over, and I get x is negative 1. So my answer is that. Wow. All right, let's do another one so you can see the pattern. Okay? Do another one. All right. 4x plus 8y plus z equals 2. X plus 7y minus 3z equals negative 14. And 2x minus 3y plus 2z equals 3. All right. The first thing I did was I looked at the first and the second. How can I eliminate the x's? Well, if I multiply this by negative 4, I'll get a negative 4x to go with the positive 4x, and that will work. So this one does not change. But this one becomes negative 4x, negative 28y, positive 12z, and equals positive 56. Those cancel out. This gives me negative 20y plus 14z equals 58. Hang on, something keeps telling me. Oh, okay. All right, that's my first one. Now I look at these two. How can I eliminate the x's? Well, this is a positive 2, so if this time I multiply that by negative 2, will that eliminate the x's? Sure it will. Distribute, you get negative 2x, negative 14y, positive 6z, and positive 28. And then you did nothing to the bottom one. The x's cancel out. I'm left with negative 17y plus 8z equals 31. So now I have two equations with two variables. You just have really ugly numbers. Who cares? With a calculator. Who cares? All right. How am I going to eliminate these? Well, I need to either eliminate the y's or eliminate the z's. 8 negative 16, 3 is 24, 4 is 32, 5 is 40, 56. All right, between 8 and 14, 56 divided by 14 should be 4. And 56 divided by 8 should be 7. Okay, so I'm going to, you're going to have to multiply both. Okay, but we're going to turn them into 56. I'm going to turn 14 into 56 by multiplying it by 4, and I'm going to turn 8 into 56 by multiplying it by 7. But I also need one to be negative and one to be positive, so they cancel out. All right, negative 4 times 20 is 80y. Negative 4 times 14 is negative 56z, and negative 4 times 58 is negative 232. Negative 7 times 17 is negative 119. positive 7 times negative 17 is negative 119y. 7 times 8 is 56z. And 7 times 31 is 217. Okay, the z's cancel out. What do I get here? 119. I get negative 39y equals this isn't coming out right because I should have whole numbers. So what did I do wrong? Oh, what did I do wrong? Okay. Did I copy it down wrong? 4x plus 8y plus positive z equals 2. 1x plus 7y minus 3z equals negative 14. And 2x minus 3y plus 2z equals 3. This one I moved over. 4x, 8, z, 2. That became negative 4x, negative 28, positive 12, and positive 56. That cancels out. Negative 28 is negative 20. Ah, my bad. What is 1z plus 12z? Last time I looked, it's 13z. So this won't work. All right. Change of plans. All right, this is no good. So what we're doing is let's just move down here. We're looking at negative 20y plus 13z equals 58, and negative 17y plus 8z equals 31. All right. We have to eliminate something on here. So we're going to have to multiply both of these by something. And really, it's going to be ugly, but we have calculators. Let's just do this. Let's multiply this by 17 and this by 20 because we'll get the same number, and one of them has to change to a positive. We'll just do it that way. It's the easiest way. All right, so 17 times 20. That positive gives me a positive 340y. Negative 17 times 13 is negative 221 with a z. And negative 17 times 58 is negative 986. This one is going to give me a negative 340y plus 20 times 8 is 160z equals 31 times 20, which is 620. All right, those cancel out. What do I get here? 221 minus 160. I get negative 61z equals negative 366, right? 986 minus 620. So we're going to divide by 61 and there we go. Divide by negative 61 and you get z equals positive 6. All right, we have a z. Now we're going to go back up into, let's just take this one, negative 17y plus 8. We have the z. Z is 6. So negative 17y plus 48 equals 31. Move the 48 over. You get negative 17y equals negative 17. Divide by negative 17, and you get y is 1. Okay, we're almost done, but we still need to solve for x. So I'm going to take the middle problem, x plus 7y minus 3z equals negative 14. That was from up above. And instead of y, I put a 1. And instead of z, I put a 6. So x plus 7 minus 18 equals negative 14. So x minus 11 equals negative 14. Add 11 x is negative 3. So my answer is negative 3, 1, 6. All right, let's try one more since I made a little mistake there. Let's try one more. Okay, got to be very, very careful. All right, x plus 3y minus 6z equals 7. 2x minus y plus z equals 1. And x plus 2y plus 2z equals negative 1. All right, first thing I'm going to do is look at these two. How can I eliminate the x? Well, if I multiply by negative 2 and add those two together, I will eliminate the x. Because what do I get here? I get negative 2x, negative 6y, positive 12z, and negative 14. This does not change. 2x minus y plus z equals 1. Negative 2x, negative 6y, positive 12, negative 14. Okay, those cancel out. I'm left with negative 7y plus 13z equals negative 13. Negative 7y. Okay, now I'm going to take these two. How can I eliminate the x's? Well, if I multiply this by negative 2, I'll be able to eliminate the x's. So the first one does not change. But the second one becomes negative 2x, negative 4y, negative 4z, and positive 2. X's cancel out. We get negative 5y minus 3z equals 3. So negative 5y minus 3z equals 3. This is what we're working with now. All right, we need to eliminate something so that we can solve. All right, well, that's a negative 7, and I'm just going to go times 5 and times 7 and make one of them negative, so it turns it into positive. Then it'll give me a positive 35y and a negative 35y. So the first one gives me positive 35y. 13 times 5 is negative 65z and positive 65. The next one gives me negative 35y, positive 21z, and positive 21. Those cancel out. This is left with negative 44z equals I've done it again. How is it? No. What did I do wrong? This is going to drive me nuts. X plus 3y minus 6 equals 7. 2x minus y plus z equals 1. X plus 2y plus 2z equals negative 1. Okay. Negative 2x, negative 6y, positive 12z, negative 14. 2x minus plus 1. Negative 6 and negative 1 is negative 7. 12 and 1 makes 13. And negative 14 and 1 make negative 13. That's correct. 2x minus y plus z equals 1. Negative 2x, negative 4y, negative 4z, positive 2. That's gone. Negative 5, negative 3, and 3. So negative 5 times negative 7 is positive 35. Negative 5 times 13z, let me do that again, 13 times 5 is negative 65. That would be positive 65. Negative 35y. Aha. Negative 21z and 21. You see how just a little? All right, so 65. So this gives me negative 86z equals 86. Divide by negative 86, and you get z is negative 1. Okay, we know z. So we go back to either one. I'm going to go ahead. I'm just going to use the second one. Negative 5y minus 3, and instead of z, I know it's negative 1 equals 3. I'm using this one right here. Okay, get this down just a little bit. All right, so negative 5y plus 3 equals 3. Move the 3 over, negative 5y equals 0. So when I divide by negative 5, I get 0. So y is 0, z is negative 1. Now I just have to go back to one of the initial problems. I'll just take the last one. X plus 2y plus 2z equals negative 1. And now I know that y is 0 and z is negative 1. So x plus nothing, so 0 minus 2 equals negative 1. So x minus 2 equals negative 1. Add the 2, and you get x equals 1. My answer is 1, 0, negative 1. All right, and the lesson most learned out of all this is be very careful because you can make such easy mistakes. All right, give it a try.